welcome to my student video. Today I will be working out number 32 from our student video number 1 problem list. And this is for Unit F, Concept 10, which is how to find the zeros of a polynomial of the 4th or 5th degree. So just for reference, we always want to input it into our graphing calculator, which I did here. And you want to take a look at your graph so you have an idea of what to expect. So when we graph this, we get this. And as you can tell, you have a bounds at one point, which means one of your zeros is going to have a multiplicity of 2. So you can always look for that. And so to begin this problem, we want to condense our options from an infinite number to a select dozen or so. So to do that, we can use the p's and the q's. So these are your possibilities for q's, and these are your possibilities for p's. And to find the p's and the q's, you set p over q and you get all your possible answers. So it would be 1 over 1, 1 over 2, 1 over 4, 1 over 5, 1 over 10, 1 over 20, as you can see here. And then you have 2 over 2, which would be 1, 2 over 4, which would be 1/2, 2 over 5, 2/5, 2 over 10, which is 1/5, and 2 over 20, which is 1/10. And so now you've condensed your possible zeros into that amount of options, which is still a lot, but you can condense even further by using Descartes Rule of Signs. And to do that, you look at your coefficient signs and you simply list them. And so here we have negative, 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 and negative. So we have no sign change, which means we have 0 positive real. And when we change the signs of the odd degree, we have negative, positive, negative, positive, negative, which is 4 changes, and you count down by 2, so 4, 2, or 0, negative real zeros. And so we start our synthetic division to find our 0 here. So first we want to start with the negatives because we know we can't have any positive real zeros. So we're going to start with -1 because it's the easiest. You do synthetic division and you'll find that you have a remainder, which means you have found your first known point, or second if you did the y-intercept. And so you want to keep going, and we'll do whole numbers first because those are easier to work with than fractions. And we use -2, we get a remainder of 90, which means we have found another known point of -2, 90. That's the function of -2, and our previous one function of -1. And so we keep going, and we're going to go to our easiest negative fraction, which would be -1/2. And when we plug in -1/2, we get 0. So we have found our first 0 here of -1/2. And our factorization would be 2x minus 1, as seen here. And so to keep condensing our polynomial into hopefully a quadratic, we keep going. And because we know our point has a bounce, our point bounces on our graphing calculator, we would like to try that again. So with our previous row that we had, we can bring that down and try -1/2 again. And when you do that, you get another 0 here. So you have -1/2 multiplicity 2, and which is 2x plus 1 squared if you want a complete factorization. So then your new polynomial would be -20x squared minus 24x minus 8. And as you could probably already tell, you could take out a 4 from that, and you get 5x squared plus 6x plus 2. And that would be your factorization, but Ms. Kirch always wants to take it a step further, so we will do that. And you can already tell this will not be like a normal polynomial that you could just factor out, so you want to use a quadratic formula. So you have -b plus or minus b squared minus 4ac over 2a. You want to plug everything in, simplify even more further, and then at the end you can even simplify by all your quadratic answer by 2, and you get -3 plus or minus I over 5. So with that, you have found all your zeros with multiplicity and your factorization. And if Ms. Kirch wants the other factorization, you could times your quadratic answer by 5x and you'd get this. And so our zeros of our polynomial are negative 1 half multiplicity 2, negative 3 plus I over 5, and negative 3 minus I over 5. Hope this helped, and see you in class.